Okay, here's the type of problem like you're going to see. It's a little bit more complicated than you're used to, but it is a difference of squares. What you're looking for is this squared, is this a subtract, and is this squared? Okay, and then you factor it as 1 plus and 1 minus. In these first two positions, you're going to find whatever it takes to multiply by itself to give you that first term. And in this case, it's x squared and x squared. Okay? You basically just take half of this, because exponent rules, when you multiply the terms, you add the exponent. So I have 2 of these, so I want half of that. Okay, I'll do another problem here in a minute. You'll see that a little bit better. Okay, now we want to see what it takes to multiply by itself to give you 256. And you can see that problem there, that it is 16 times 16. So that goes here and here. So when you FOIL that back out, I'm just going to show you, and then I'll erase it. You get x to the 4th minus 16x squared plus 16x squared minus 256, and those middle terms cancel out, so you have x to the 4th minus 256. So it worked, right? Okay, but we're not done. We still have a difference of squares here. It's a subtract. This is squared, and this is 4 squared. So you have to go one more time. This first factor of the add 16 cannot factor because it's an add. There's no such thing as a sum of squares. It's only a difference of squares. So we're going to do x and x in your first term, and 4 times 4 gives you 16. 1's plus, 1's minus. Okay? And you are done. It's a horrible rectangle. Okay, so if it's plus, you can't go any further. If it's minus and these two are both squared, you continue one more step. Okay, this one. What you need to look for on this is a common factor between the 3 and the 27, because 3 is not a perfect square, and neither is 27. But once you take a 3 out, because 3 goes into both, you have a difference of squares. Okay, so I didn't see any of these on your homework, but I didn't ask for another problem. You know what I mean? So you might get one of these. That's why I wanted to throw it in. Besides, we get extra practice right here. Okay, so you want half of your exponent, so that's going to be n squared and n squared. And we want what do you multiply by itself to give you 9, and that would be 3 and 3. 1 plus, 1 minus. Okay, now in this case, you want to see if you can go further because you have n squareds, but since this 3 is not a perfect square, you cannot go any further. You're done. Okay, so what would it look like if you could go one more step? Okay, sorry about the little glitch. So we're going to have a 3 in common again. So this is a new problem. So you take out the 3 from both terms and you end up with an 81 here. Okay, so you leave the 3. We're going to factor this difference of squares. Half of n to the 4th is going to be n squared. Technically, it's not half of n to the 4th, it's half of the exponent, so half of 4, right? 1's plus, 1's minus. And what do you multiply by itself to give you 81? 9. However, this part you can keep going because this is a difference of squares. N times n and 3 times 3, and it's subtracted. Okay, so one more time. You leave everything else. We cannot factor this part because it's an add, but this part we can. So we have an n and an n, a 3 and a 3, 1 plus, 1 minus. And you're done. Okay, so this one's done here, and this one is done here. Okay, one more. And again, I didn't see anything exactly like this, but I want to be safe. Okay, so when you take out your common factor, in this case, you have n's in both, so you have to use that as part of your common factor as well. Okay, so, whoops, you take a 2 and 2 n's. You take the lowest exponent, right? So 10 and 2, 2 is the lowest. Okay, so what do I have left? I have n to the 8th, because I want to take 2 n's off of the 10, and I have 8 left. Minus 25, and the n is out front, or the n squared is out front, so I don't have any n's. Okay, so this is your common factor out in front. Now this is a difference of squares. So we know it's 5 and 5, 1 plus, 1 minus. But now you take half of the exponent, which would be 4. Okay, so n to the 4th, n to the 4th. Now because you can split this one in half, and it's a subtract, you have to look here and see if that is a square. Since it isn't, you're done, and we don't need to go any further. Okay, it would be a lot bigger number here in order to get this one to be able to factor again. Okay, so if this number is really big, you're going to want to see if you can go one more time. Okay, all right, so there is those. I hope that helped. Did I just say there is? How about there are? There are those. There we go.